Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 10th of electronics, in which I'm going to discuss semiconductors and clippers. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also guys, please share my lecture details to your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, so let's get started. So this is semiconductors guys. Okay, semiconductors, we have studied it. So semiconductors in 11th 10th we have already studied semiconductors. Okay, so here guys, semiconductors are, so we use for making semiconductors as silicon, germanium, right? So in semiconductors, there's a conduction band. I'll show you. Okay, so this is conduction band and this is valence band. Okay, this is valence band and this is the energy gap. Okay, so in semiconductors, the band gap is the delta Eg, that is band gap between a conduction band and uh, valence band is 1 to 2 electron volt. Okay, 1 to 2 electron volt, so it's very less. Okay, and for if you talk about silicon, that semiconductor, for silicon, delta Eg, that band gap is 0.7 electron volt, right? Okay, and if you talk about germanium, GE, for that the energy band gap, that is delta Eg equal to 0.3 electron volt. Okay, so this is the band gap for silicon and germanium. Okay, so the band gap between conduction band and valence band for semiconductor is between 1 to 2 electron volt, which is very less. Okay, and so if we talk about silicon, right, we have silicon. So silicon has there are 4 outermost electrons for silicon, right? So this is one. Okay, so this needs to be updated. This one. So there are 4 outermost electron in silicon. Okay, so so now there is intrinsic semiconductor and extrinsic semiconductor. Okay, so there are 2 types of semiconductors, that is intrinsic semiconductor, and extrinsic semiconductor. Intrinsic and extrinsic, guys. Okay, extrinsic semiconductor. Okay, So intrinsic semiconductors are pure semiconductors like germanium, silicon, okay, and extrinsic semiconductors are impure. So there is a doping in the semiconductor, okay. So impure, this is impure. Impure, okay. And so intrinsic semiconductors has low conductivity, guys. Low conductivity, low conductivity, okay. And whereas extrinsic semiconductors, that impure semiconductors, because of doping in pure semiconductor, right, uh, they have high conductivity, okay, high conductivity. And for intrinsic semiconductor, Np is equal to Ni square, okay. Np equal to Ni square, okay. And if we talk about extrinsic semiconductors, so there are two types of extrinsic semiconductor, that is N type, that is N type, and P type, N type and P type, okay. So N types are made from trivalent atom, guys, trivalent atom, okay, trivalent atom. And P type semiconductor are atoms made by pentavalent, pentavalent, outermost electrons are 5, okay, pentavalent atom, pentavalent atom, pentavalent atoms, okay. So trivalent atom are such as aluminum, that is gallium, okay, I2. And similarly for pentavalent atoms are lead, arsenic, sorry, P, arsenic, phosphorus, arsenic, and Sb, antimony, okay. So this is these are impure this extrinsic semiconductors, which are useful, okay, very useful, okay. So now next is, so N type, N type, so donor atom. So in for N type, donor atom, there is donor atom in N type, donor atom impurity, okay. There is donor atom impurity, that is Nd, okay. And here N is almost equal to Nd, okay, or Np, since we know Np equal to Ni square, right. So from here P value is going to be Ni square upon Nd, because N is almost equal to Nd, okay. And for P type, these are acceptor atom, acceptor atom, acceptor atom impurity, acceptor atom impurity, okay. And here P is that number of electron, that P is almost equal to Na, number of acceptor electrons, this is number of donor electrons, okay. So from here this is Na, guys, okay. N, okay. And N is, then in that case N is going to be equal to Ni square, Ni square upon Na, okay. Ni square upon Ne. This is I, okay. I. Next is that if you compare conductor and semiconductor, okay, this is conductor and semiconductor. Conductor and semiconductor. This is going to be like here the conductive for conductor the current density is, we know, that is Ne, Ne, NeVd or Ne mu E, Ne mu E, Vd equal to mu E, right? Mu E, Ne mu E. Mu is the mobility of electron, right, or hole. So it's so electron, right? Mobility of electron. So J equal to Ne mu. Mu is the mobility of electron. N is the number of electron, and E is the charge on the electron. We have studied this in class 12, 11th, 12th. Okay, this. So, but if you talk about the semiconductor, the current density is Je plus Jp. Current density because of electrons plus current density because of holes. Okay, so from here uh, this one, and for conductor the sigma conductivity is Ne mu, guys. Ne mu. Okay, if you talk about this semiconductor, the current density is this, then we'll put the value. So J equal to J is going to be same for electron, that is Ne mu E, Ne mu E, right, is the electric field. Mu is the mobility of electrons, mu E, plus Pe mu Pe, where mu P is mobility of holes, or J is going to be equal to, here we can take common, that is E we can take common, right? E is the charge on electron and E is the electric field. E we have taken common, capital is electric field, then it is mu E plus P mu E, mu P. Okay, so this is the mobility of, mu P is mobility of hole, mu E is mobility of electron, and P is the this number of holes, and N is the number of electron. Okay, so this is the current density for semiconductor, and this is the current density for conductor. Okay, this is also important. These formulas are important, guys, so you need to note down. Now this one, N type and P type semiconductor. Okay, P type and N type, P type and N type. So P type and N type. Okay, so here this one. Okay, so this is so for P type, so there are hole, okay, so they need electron, right? So this is P type. They are acceptor atoms, so these are acceptor atom. Okay, acceptor atom. And if we talk about N type, so this is one. Okay, this is There are electrons in n type, right? Electron are the charge carrier in n type. Electrons are the charge carrier. Okay, so this one. So this is donor atom, right? Okay. Donor atoms. Donor atoms. Okay. This is p type. So here these are holes. They accept the electron and they are donor atom in p n type. They have they are donor atom, right? So they donate the electron. Okay. And this is the one. This is the p type and n type semiconductor. Okay. Now I'll make a figure that p-n junction. Okay. So I'll explain p-n junction. Okay. This one. Okay. These are holes, acceptor atom. Okay. So here these are this one atoms. Okay. These are the electrons. Okay. So here this hole will move from here. Okay. And these are the electrons will move here. So if they, here you can see there will be when you can see here, so there will be depletion if we connect these n type and p type. So we'll see here depletion layer. Okay, so this is the depletion layer, guys. Depletion layer, depletion layer. These are depletion layer. Okay, this is p and these are al. Okay, this is aluminum p type. Okay, and here this is called depletion layer and also diffusion. 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 Okay, or this is called, this is also called, this layer is also called recombination region. This region is called recombination region. Okay, recombination recombination region. Okay, just give me 1 second, guys. Okay, recombination region. Okay, this one. And now so this is the p-n junction. Okay, if we connect p-n p type semiconductor and n type semiconductor together. Okay, like this, p type and n type. And here you can see this is the depletion layer and called diffusion. Okay, and now we'll do biasing for these two semiconductor. Okay, we'll do biasing. So here so there are two types of biasing we are going to do, that is forward biasing and reverse biasing. Okay, so this is the case of forward biasing. So this is the depletion layer. Okay, and these are electrons. This is N type and this is P type, and there is hole. Okay, these are holes. So holes goes there like this. Electron like this. Okay, so this is the depletion layer. Okay, and before that I'll explain this one. Okay, so due to, I'm writing this one, due to recombination of electrons, recombination, due to recombination of electrons and holes, they recombine, right? Recombination of electrons and holes because of concentration difference, because of concentration difference. Okay, so due to recombination of electrons and holes, and also because of concentration difference, okay, an electric field is developed, and electric field, that is EF, is developed across the depletion layer, across the depletion layer, which further generates a potential difference, generates a potential difference which further generates a potential difference across the junction known as junction voltage, or barrier potential, or barrier potential. Okay, so this this is P type and this is N type, guys. Okay, P type and N type. P type and N type. When we connect when we connect P type and N type, so there's a PN junction. Okay, and which is called there's a PN junction layer, and that is called depletion layer. Okay, and the electron will pass from will come this side, and electron will come this side, and holes will move this side, right? They will move in opposite direction with each other. Okay, and due to recombination of electron and holes, and they recombine, right? Because of concentration difference, and the recombination of electron and holes, what will happen is the electric field is developed across the depletion layer. So this is the depletion layer, and electric field is going to get developed because of this, okay, because of recombination and because of concentration difference, okay, and which further generates a potential difference, and because of that the potential difference gets generated, okay, across the junction known as junction voltage, and that that voltage is known as junction voltage, or that barrier potential. That potential is known as junction voltage or barrier potential, okay. So potential will get developed across this junction, guys, okay, across this across this depletion layer, okay, and that is known as barrier potential or junction voltage, okay. Now we'll do different biasing, okay. So this is the PN junction, okay, and we are doing forward biasing in this case, okay. So this is case of forward biasing, okay. This is N, this is P, and this is forward biasing, FB. I'll write in short FB. This is forward biasing, guys, okay. And there is reverse biasing as well. So in reverse biasing, I'll show that case as well, the reverse biasing case. Okay, reverse bias, this is P and this is N, okay. So there are holes, there are electrons, okay, and here because it is in reverse bias, okay, this is in reverse bias, minus plus, okay, and this is plus minus, okay. So this is in reverse bias, that is FB, my apologies, RB, reverse bias, okay. In short, we can say RB, reverse bias. So in reverse bias, here what will happen is this layer, this is a junction layer, depletion layer, that will the size of this will get increased, okay. The width of this junction will increase in reverse bias case. In forward bias case, the depletion layer, the width of depletion layer will decrease, okay. So and in forward bias there would be current, okay, current will flow, and because of majority of charge carriers, okay, because of majority of charge carriers, okay. And if we talk about the reverse bias, so here the current will there will be very less current, and that will be because of minor charge carriers, okay. So current is, this is majority charge carrier, majority because of majority charge carriers, majority charge carriers, majority charge carriers, and here current is minority charge carriers, okay, charge carriers in the case of reverse bias, okay. And also the depletion, so in case of forward biasing, depletion layer the width decrease, okay. So depletion layer width will decrease, okay, and this is because of forward biasing. And in this case, you can see here, this is the depletion layer, and this got increased, okay. So here in case of this reverse bias, the depletion layer depletion layer depletion layer width will increase. Okay, will increase. Okay, so this is about that this is the PN junction and depletion layer, how the depletion layer becomes. Okay, I've explained that depletion layer. Okay, and after that there are two types of biasing for PN junction, right? So forward biasing and reverse biasing. So in in forward biasing, we can see depletion layer will decrease, and there will be current that will flow because of majority charge carriers. And in reverse bias case, there will be very less current, and that will be because of that minority charge carriers. Okay, and the width of depletion layer will get increased. Okay, this is the one. And now I will make a graph. Okay, I'll show the graph for forward biasing and reverse biasing together. Okay, very important graph. Okay, and the graph is V versus I, current, that voltage versus current. So if we talk about this forward biasing, the graph will be like this. Okay, so this is the case of forward biasing. So initially the current will be very less, and then suddenly it will get increased. Okay, and this is because of depletion layer. But after some time, forward biasing, depletion layer width will decrease and current flow will increase. Okay, and if you talk about reverse biasing, so this is like this. Current will be very less, and at certain voltage suddenly the current will increase rapidly. Okay, and that voltage is called, that voltage is, suppose that is V2, and that voltage V2 is called breakdown voltage. Okay, break breakdown breakdown voltage. Okay, so this is the graph for reverse bias, and this is graph for forward bias, guys. Very simple. Here you can see initially for in case of reverse bias, the current will be very less. Okay, and but at certain voltage, that voltage is called breakdown voltage. Okay, at this voltage the current will increase rapidly. Okay, this is the graph. Okay, well, this is the one, guys. Okay, so guys, there's a clamper as well, clippers. Okay, okay, guys. So there is a clipper. So clipper I'm going to start in next lecture. I'm going to stop here. Okay, so guys, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends so that they will also be able to watch my live lectures and will be benefited from it. Okay, in next class I'll start clippers and clampers, guys. Okay, okay guys, so okay guys, thank you so much. Bye now.